Hi. So in today's video, we are going to go through part 21. That's a revamped enemy spawning system. So the reason we are doing that is because, well, there are a couple of reasons for that. Okay, so this part of the series has been planned for quite a while, but I kept getting derailed because I kept detouring to address something else, like fixing the pickup collection system or improving the UI. It's just problems I found along the way with various parts of, okay, I won't say problems, but inefficiencies I found with certain parts of the series as I went through the different pieces of code that powered different parts of the game. So the enemy spawning system revamp has been planned for a while now, and the reason for that is because there are a couple of inefficiencies with the way that our current enemy spawning system works. So let's go through some of them. Alright, so if you follow our project, you would have the enemy spawner component attached to a game object in your scene called enemy spawner. Alright, and this enemy spawner will contain wave data, right? So if you wanted to have different waves of enemies, you will key in all the waves over here. And that is the first problem that we have over here, alright? That say now if I have the same wave, so for example, if I wanted to spawn a bat for the first wave, and I wanted to spawn a bat again maybe for maybe the fourth wave or something, right? Or you see, if you look at wave number 3 and 4, they are the same. Alright, but then I can't reuse the data. The reason I can't reuse the data is because the wave data is embedded directly inside the enemy spawner. So if I wanted to reuse a certain wave, I would just have to duplicate the wave. Okay, this is a little bit inefficient because you're storing the same piece of data multiple times, and that is something that we don't want. Alright, the other reason that this wave structure, this array over here that stores the wave data isn't very good is because, let's say right now I accidentally remove, so I set the wave to 1. Oops. And then if I try and get back my data, it's a little difficult, right? Data is all gone. See that? Data is all gone. The red bats are gone. And now it's all just a duplicate of the first wave. So it's really easy for us to accidentally delete data from our waves in the enemy spawner. And this is something that we want to change. We don't want to store the wave data directly inside the spawning script that we have. We're gonna create a scriptable object that we can assign to the array here instead. The last problem that we have with this enemy spawner is that, well, it's not very self-documenting. What do I mean by self-documenting? Alright, so when you look at a component, let's say if I add a rigid body, right, in Unity, I would say that the rigid body component is self-documenting because every single attribute that you have over here is meant to be adjusted. Alright, and then there is a name that kind of tells you what the property does. Okay, if you've never worked with game engines before, maybe what collision detection is or what interpolate is may not be that obvious. But these two things are things that you can find in every game engine. So are kinematics. Alright, so in a sense, these properties are self-documenting. We can't say the same for our enemy spawner script because our enemy spawner script, within there are some variables that are not meant to be set by us. Okay, so these variables are public, but they are not meant to be set by us. Let me give you an example, right? Let me just run this game over here, and then we'll look at the enemy spawner component. Let me just unmaximize this. Okay, so what we have over here is, notice that this variable over here is not meant to be updated by us. The game updates it on its own. So enemies alive keeps increasing. And then when I kill something, enemies alive will reduce, right? See that? And then we have the current wave count also, which is not controlled by us. And then inside the waves data as well, you will see that some of the variables here are not controlled by us. For example, spawn count is not controlled by us. Okay, and inside enemy groups even. Okay, there are certain values here that are not controlled by us. So what are the variables that we are supposed to set, and what are the variables that we are supposed to leave alone? This is not clear in our component. So this means that there is room for this enemy spawner component to be better designed. Better designed in the sense that now we want to make it more self-documenting, so that when we look at the variable, we don't have to think, is this variable supposed to be set by us, or is this variable supposed to be set by the script? You get what I'm trying to say? I hope my explanation is clear enough. So because of these three reasons, that the waves array over here is difficult to manage, easy to delete the data. Say if I accidentally change this value, this will remove some data that I have, and it's not clear that the variables, which are the variables we are supposed to set and which are the variables we are supposed to leave alone. So for these reasons, we want to revamp the enemy spawner to make it more intuitive to use, more self-documenting, meaning when I see the enemy spawner, I should be able to know what variables I have to set to be able to get it working. And one last reason as well, right, is that the relative spawn points that we have, right? Okay, currently when we spawn the enemies, we manually place the spawn points around the player, and the enemies always spawn at these spawn points around the player. So what this means is that if I have a very large screen, you will find that the spawn points may sometimes be within the camera boundaries instead. You see that right now the enemies are not spawning outside of the camera, they're spawning inside of the camera. Yeah, and this makes it so that this only works if your screen is a certain size. If your screen is too large, the spawn point will lie inside the camera. And well, the whole point of the last two videos that we were doing was to make our game adaptive, right? So then now that our game is incapable of accommodating a larger camera, this makes it very unadaptive. So the last reason that we want to redo the enemy spawner is because we want to make it so that the enemies always spawn outside the camera, regardless of how big or how small our screen is. We don't want a big screen to have the enemy spawn within the camera itself. This obviously is not adaptive, and it's not something that is a very good thing for our game. Okay, so for these reasons, we are going to revamp the enemy spawner. And the first thing we are going to do with the enemy spawner is we are going to create a couple of data structures to support our enemy spawner. Okay, what do I mean by that? Okay, the first thing we are going to do is, okay, let's first go to our enemy spawner script, the old one, and then we will set the enemy spawner script to be obsolete. This tells us, or this tells Unity that, hey, we're not going to be using this script anymore. So it's just a very simple message that we are putting here, so that wherever we have the enemy spawner, we will label it as, we will have a warning over here, replaced by the spawn manager. Over here it also says deprecated. This is something that we've done for some of our older scripts as well, right, in part 15 and 16. So next thing we want to do is we want to create a new set of classes, and these classes are scriptable objects, and they are meant for us to create wave data. What is wave data? Wave data is just data about enemies that are spawning in a certain wave of our spawn system. Let me just grab the data first and show you how this looks like. So I'm gonna put all my new spawning scripts into a folder called scripts, and it's gonna be called spawning right here. Okay, so the new folder is scripts spawning. Then I'm gonna create a new script called spawn data. Spawn data will serve as the basis for all of our spawn information later on. We're gonna have different kinds of spawns. Okay, in Vampire Survivors, there are two kinds of spawns. The first kind of spawns are the default spawns, where you get spawns every couple of seconds. And then the other kind of spawns are, the spawns like the flower wall, or the spawns like, you have mobs flying across the screen, right? Those are event spawns. We want to be able to have our spawn data support both these kinds of spawns. The event spawns, which spawns a much larger number of enemies in a shorter amount of time. And then we also want the regular spawns. These are the spawns that happen regularly every 1 or 2 seconds. Right? So the spawn data is going to be the basis, and it's going to be abstract. What this means is that you are not going to be able to use the spawn data directly. This creates the base for the other kinds of spawn data that we want to use later on. So it's going to be abstract, and then let's also copy the wave data script and put it into the project. So the wave data script is here, and what I'm gonna do here is after I create this script, let me just show you what's going on in Unity now. So the wave data script allows us to create a new kind of scriptable object. I'm gonna create a new folder in the scriptable objects folder, and I'm gonna call this folder wave data. And this will contain data for all the waves that we have in our game, and this also avoids repetition, right? One of the things that we set out to solve was that we had to repeat data in our own enemy spawner if we wanted to spawn the same groups of enemies. Okay, now with wave data, we don't have to do that. Okay, by adding the wave data script into our project, we can now create a new scriptable object called wave data over here. Okay, so I'm just gonna name the first wave bad wave 1, and what this is going to do is that once I select this scriptable object here, you will see that I have a couple of properties that I can modify, and there are 2 parts to this scriptable object, right? You have the first part over here. The properties over here are provided by spawn data. Okay, so what spawn data contains are basically properties that you can modify to control, number 1, what is spawned by this wave data or this spawn data. All right, so I'm just gonna spawn some bats. So I'm just gonna put bat over here, and because I want to spawn, if I want to spawn multiple kinds of enemies, right, I can actually add multiple items inside over here. What I'm gonna do here is I'm just gonna make this wave spawn regular bats 75% of the time, and I'm gonna make the wave spawn a special rate bat 25% of the time. So I put in 3 bats and then I put in 1 red bat. Okay, so if you want to modify the probabilities of certain prefab spawning, then let's say if I want to have maybe a 60% chance of spawning bats and 40% chance of spawning red bats, then I would do it as such. So you just repeat the prefabs as many times as you want to adjust the ratios for how often you want certain types of enemies to spawn. The second property over here is spawn interval. Spawn interval basically controls how long between 2 spawns. All right, so if I want a spawn to happen every 1 to 2 seconds, I will set the spawn interval to be 1 to 2. And then for the spawns per tick over here, this controls how many enemies are spawned every interval. So if I want maybe 4 to 5 bats to spawn every 1 to 2 seconds, then I would set spawns per tick to 4 to 5. And duration here basically controls how long the wave lasts. Alright, so just from the first few properties over here, you can see that the variables that we are using here are more descriptive than the enemy spawner variables that we have here. I found it really hard to determine how many enemies to spawn, and you know, there were a lot more fields for me to play around with here, and I just found it a little bit confusing when I was using it. So if you're wondering why is it that I created this, if I'm running this series, why am I confused by my own code? It's because I took over this series from Xavier. He did a great job at starting off the series, and there were certain parts of the series that he did very well. But then because he had to make the code simpler, because he was going to detail with a lot of the codes, right, in the earlier parts. So then he decided to make the code simpler so that he could explain, so that it was easier for him to explain the code in depth. And then from part 15 onwards, right, because I wanted to make the code that we have more robust, so then I decided to make the code more complex, but at the same time make the components easier to use. So it's always a trade-off, right? If you put the complexity in the code, then your components will be easier to use. Otherwise, if you make your code simpler, if you want to explain your code a lot, I guess that means that you have to make code simpler. That means that your components may be a little bit harder to use. So I thought that, with 14 parts of us going through the basic stuff, it was time for us to touch on the more advanced parts of coding, and that was why I decided to bring in more advanced concepts, which in the long run is going to make our project easier to manage and easier to use. So these 4 properties over here are given to us by the spawn data, and it's abstract, which means that, again, you cannot create a spawn data object. All right, you can only create wave data objects. Sorry, this is the wrong script here. Let me just delete this. So you cannot create a spawn. You cannot create a spawn data object. You can only create a wave data. Okay, because the wave data is not abstract, but the spawn data is abstract, and the wave data, because it inherits from a spawn data, it inherits all the properties that the spawn data has. Okay, there are a couple of functions in spawn data as well that are just there to allow us to easily get data from the spawn data, because we have a couple of possible spawn prefabs, right? So it's going to be quite difficult for us to manually retrieve the spawns. So then we have a get spawns function that will generate a list of enemies. So let's say if you want to generate 5 enemies, then you will just call get spawns and then put 5 in the argument over here. This will give you 5 enemies that are randomly selected from the possible spawn prefabs. We also have a function here, get spawn interval, that basically gives us a random number between the 2 spawn interval values that we have over here. Okay, so on top of data that you have in spawn data, you have also functions that allow you to more easily get the values that you want out of this scriptable object. Later, when we go on to the spawn manager, you will see how these functions are used. And inside wave data here, you have a couple of variables that are unique to the wave data. And the first variable over here is starting count, which controls how many enemies should be there the first time this wave starts. So in Vampire Survivors, this restriction is there as well. So if you notice, if you start a new wave, sometimes you just suddenly have a lot of enemies coming at you. This is because they have a starting count mechanism that you can set. So let's say if the wave starts and I set the starting count at 25, what this means is that it's going to be a bunch of bats. At least 25 bats will spawn. Alright, if there are less than 25 enemies on the screen, then we will spawn bats here until we get 25 enemies on the screen. Total spawns controls how many enemies this wave is allowed to spawn, and if you set it to a low limit, then after the total spawns are met, then the wave will stop spawning enemies. Finally, we have exit conditions and must kill all. These are just ways for us to control. These are additional features. They are not in the original Vampire Survivors, and they are ways for us to control how we want the wave to progress. Okay, so the default over here is wave duration, which means that the wave will last for 60 seconds, and it will move on to the next wave in the spawn manager that we're going to create later. Okay, you can have other options as well. You can set the exit condition to be wave duration and reach total spawns, which means that if I select these two, it means that I need to wait for 60 seconds, and I need to also wait for the wave to spawn up to 4 billion enemies over here. Okay, probably not very realistic. So if you set a lower number here, then you can set an exit condition that is not just the wave duration. Okay, or you can also make the exit condition only reach total spawns, which means that you have to wait for 100 enemies to spawn before the wave will end. Alright, so just gives you a little more flexibility on how to advance the waves in the game. And finally, we also have a must kill all. If you check this, then you must kill everything in the wave for the next wave to spawn. And that about wraps it up for the wave data scriptable object. Next thing we're gonna do is to head over to the article and grab our spawn manager script, because that will allow us to create a new spawning system that we can use to spawn our enemies. So hi Gentleman Gaming, it's nice to see you. And yeah, I'm glad to be able to fix this as well. So it really annoyed me whenever I saw that the wave data was removed when you change the, I mean, there were other things that annoyed me as well. It's mainly with how difficult to use the enemy spawner was, which is why this recording is happening. Just want to point out one more thing regarding the wave data. With the wave data over here, we actually have a function. Okay, these are all the extra variables that we are setting. Notice also for both the wave data and the spawn data, we have tooltips. Tooltips are there again to make the code, the scriptable object, easy to use, because with the tooltips here, this means that when you mouse over the properties, you will get a help prompt. Okay, which is really great if you want to document what every property does. So the codes that we are creating for the past couple of parts, they may contain a lot more text, but this also means that it's a lot easier, it's a lot cleaner for us to use. Okay, so I hope these two tips help for those of you who maybe are not very familiar with the code that we are doing here. The tooltips, if you use them, then that will make it easy for people who are using your code to create the games that they want. So in the wave data script, I also have a function here, get spawns, that overrides the original get spawns function. And the reason that it overrides that is because in the wave data, notice that we have a starting count. All right, so what this means is that if you call get spawns from the wave data, if they are less than, let's say if you set the starting count to be less than 25, then there's an extra line over here compared to spawn data, because what this does is that if there are less than this number of enemies on the screen, then we will increase the number of enemies to spawn to be equals to starting count minus total enemies. So let's say if you are supposed to have 25 enemies on the screen, and right now you only have 7 enemies on the screen, then this function, instead of giving you, let's say if you want to spawn 5 enemies, instead of giving you 5 enemies, it will give you 17 enemies, so that it makes up the difference and you will meet the starting count number of enemies. Okay, this is just a small thing because we have a little property here that allows us to set how many enemies there are at minimum when the wave starts. So with that being said, I should have explained everything in the spawn data and wave data code. So let's move on to creating the spawn manager. So the spawn manager is an even simpler component to deal with. Let me show you what I mean by that. Let me just go to scripts over here and go to spawning, and let's create a new script here, spawn manager. So this new spawn manager script here is largely fine. Okay, it's just missing a couple of, if you copy and paste the spawn manager script into your own project, you will find that there are a couple of red lines, and this is all because it refers to a variable called enemy stats count. Okay, so let's also head over to enemy stats script, and then let's make the following changes. Okay, we want to add a new static variable here, count. And then how we're gonna manage this variable is simply we're just gonna, whenever we have an await function over here, we're just gonna do count plus plus. And then wherever we destroy an enemy, we will do a count minus minus. What this does is that whenever we have a new enemy stats component on the screen, we will increase the count over here. And then whenever we remove an enemy stats component from the game, then we will decrease the count over here. So in a way, this count variable, because it is static means that it is not tied to a particular instance of the object. Okay, regularly when you have a variable, the variable is tied to a particular copy. So let's say if you have 5 enemies on the screen, then you will have 5 different enemies with 5 different health, right? So for example, enemy stats here has current health. So if you have 5 different copies of enemy stats on the screen, then you will have 5 different copies of health. Static variables are not like that. Static variables are shared across the entire class, which means that if I have a static integer count here, this applies to all copies of the enemy stats. They will all share the same value. So then when I update this, what this tells me is this variable here just maintains the number of enemies that are on the screen. Alright, so the spawn manager needs a variable called count, and then once you add the enemy stats count variable, and of course you also have to add the code to track how the count variable works, then this will solve the issue that you have on the spawn manager. So the spawn manager is pretty simple as a component. Let me just check if I missed out anything in the enemy stats script first, yeah? Okay, so then once we add the count variable, then our spawn manager works. Later on, we'll make a couple more changes to our enemy stats script. For now, let me just attach the spawn manager onto our enemy spawner. Okay, I'm just gonna disable the old enemy spawner component and show you how the new enemy spawner works. The new spawn manager is straightforward. Okay, you just have a data array, and then this data array here you can just assign wave data objects onto the data array, and then this will allow you to set how many waves there are. So for example, if I want to add 3 waves to the game, I can just assign this wave scriptable object to the spawn manager multiple times, and then this will give me 3 different waves with the same data. Of course, if I want to spawn, let's say, just all red bats, then I will have to create different waves. Or if I want to spawn skeletons, zombies, and whatnot, then I will just create different waves. Okay, the reference camera over here is because the reference camera automatically will be set to the main camera, and the maximum enemy count will be set to 300. Vampire Survivors is a limit of 300 enemies. So that's why we put this in the spawn manager. If you don't want to have this limit, just set the enemy count to 0 or just set it to a very high number. Okay, the 300 enemy limit is just for performance reasons, but you should be able to have more than 300 enemies. Okay, but that depends on your device as well. So 300 seems like a good number just because Vampire Survivors chose this number. Alright, so the spawn manager as a component is pretty easy to use. Reference camera is just used to determine where the enemies should spawn, and it will always spawn outside of the reference camera. Okay, the spawn manager script itself has a little bit more complexity, but a lot of the complexity is inside the update function. So let me just run through the update function a little bit. Okay, so we have a couple of private variables. Okay, we have the spawn timer in the spawn manager, which basically tracks when is the next time you can spawn the next group of enemies. We have the current wave duration, which is, if you recall, every wave has a duration, right? So like the wave that we have over here has a duration of 60. Right, so then the current wave duration tracks how long the wave has been running. And then between these two things, right, so every time update runs, you will decrease the spawn timer. Spawn timer is basically the cooldown, right, for when the next spawn will happen. Current wave duration is how long the wave has been running. So if the current wave duration exceeds the duration of the wave, then we will move on to the next wave. So every time update runs, we will check if spawn timer is less than 0. If it's less than 0, it means the next set of enemies are ready to spawn. If that's the case, then we will check whether the wave has ended. Right, so the has wave ended is a function that you find somewhere else in the script. And has wave ended basically checks if the current wave has ended for various reasons. So here we check the exit conditions, and we see whether the exit condition is wave duration, because recall that we have wave duration and reach total spawns over here. Okay, so we check whether the wave duration is a wave condition. If it is, then we check if the current wave duration is more than or less than the duration. If it's less than, it returns false, which means that the wave has not ended because the wave's duration is still less than the current wave duration. Okay, then we check whether the exit condition includes reach total spawns. If it includes that, then we will check whether the current amount of enemies that are spawned. This is something that is tracked by the script as well. It tracks how many enemies have been spawned by the wave currently. So then it checks whether the current number of enemy spawned by this current wave is it exceeds the total number of spawns that this wave can have. And if it's less than that, then it returns false. Otherwise, we will check whether the must kill all checkbox, which is right here, whether it's checked. If it's checked and then the enemy stats count is more than 0, then it returns false. So all these are conditions for checking whether the wave has not ended. And if all these conditions fail, then it means that the wave has ended and returns true. So this is just a way for us to check whether the wave has ended. And if you want to add more exit conditions in the future, then you will have to add more conditions into the has wave ended function right here. So once that is done, let's go back to the update function. So if the wave has ended, we will advance the wave. Right, then we set the wave duration to 0, and we set the current wave spawn count back to 0 as well. And then we will set the current wave index to be one number high. See that? And if the current wave index is more than the number of items in the data length, the data is basically this array over here. Sorry, it's not this one. Data is the array over here. So if you have already exceeded the maximum number of waves, there is a check here. And then it says here, if you already exceeded the number of waves, then all waves have been spawned, and then we will shut down the spawn manager. And then we will end the function over here. Because once we advance the wave, or once we detect that all waves have been spawned, then we shut down, then we will stop the script. Alright. So if the wave has not ended, then the code will come over to here, where basically we are checking if we are able to spawn enemies. Okay, so there are a couple of conditions under which we will not be able to spawn enemies if we have exceeded the maximum number of enemies. Remember that we have a limit here. If we exceed the number of enemies, then we will not be able to spawn enemies. Otherwise, we will not be able to spawn enemies as well if the current wave spawn count is more than the total number of spawns allowed for that wave. Again, this is set inside the wave itself. In the wave, you can set for there to be a limit of, let's say, 100 spawns. Alright, if you set a limit over here and you exceed the limit, then the wave will not be able to spawn any new enemies as well. Okay, this will apply more for if you have a must kill all, for example, and then the wave duration is exit condition. So even if you've spawned, after you spawn 100 enemies, maybe you want to stop enemies spawning, then you can play around with the variables over here to determine how the wave ends. Okay, it doesn't always have to end after 60 seconds have passed. And this is where the complexity comes in when it comes to our has wave ended function. Okay, so the can spawn, okay, if it returns true, then we will be able to spawn more enemies. So if can spawn here fails, then what's going to happen here is that we are going to reset the cooldown. Spawn timer here, we are getting the spawn timer here and adding the random spawn interval value to it to reset the spawn cooldown. Okay, so if we cannot spawn anything, we reset the cooldown and then we stop this function. Otherwise, we will use get spawns on this is basically one of the items inside the spawn manager. Recall that these are all wave data objects, and wave data objects have a function called get spawns that basically generates an array of all the enemies that you should spawn in order. Alright, so let's say if you want to spawn 6 enemies, for example, if the next spawn has 6 enemies, then get spawns will give you an array of 6 prefabs, and you will just instantiate all of these prefabs to spawn the enemies. Okay, so once you spawn the enemies, or rather once you generate the spawns that you want to have, then you have to loop through all the spawns, and then again you check whether you are able to spawn anything at this point. If you're not able to spawn, then you just move on with the loop. Alright, otherwise you will create the prefab and then you will generate a random position and then increase the current wave spawn count. Of course, finally you also want to reset the cooldown for your spawn manager. Okay, so the last function that you want to go through here will be generate position. Generate position is a function that basically is a static function that basically picks a point that's right outside of the camera. Okay, how does it do that? It basically, over here there is a random range of 0 to 1 and 0 to 1. Okay, and what's happening here essentially is that if you think of a camera, right? Let me just draw everything on in paint to illustrate this to you better. The camera is gonna be a rectangle, and what you want to do is you want enemies to spawn in 4 of these edges. Okay, you want enemies to spawn either here and here, or here and here. So what this means is that you will randomize either the X or the Y direction. So let's say if I want an enemy to spawn anywhere on the line that's on the top, this means that I have to randomize the X, but then the Y value will always be, let's say the Y over here is 0 and this is 1, and let's take this as 0 and let's take this as 1. So I need to randomize either the X or the Y. So if I randomize the X, then I can put the Y at either 1 or 0. If I randomize the Y, I can put the X at either 1 or 0. And that is essentially what this piece of code does over here. It picks a random X and random Y, but then we will randomly choose between two numbers. Okay, so random range over here, if I put 0 and 2, what this does is that it will randomly generate a number between 0 and 1. There will not be a 2 because these are integers. Whereas over here, I do a random range 0f to 1f. What this means is that it will generate a random number that has decimal points. So between 0 to 1 can be 0 0.5, 0 0.372, 0 0.755, any number between 0 to 1. Okay, over here, this is just strictly the numbers between 0 and 2, which is 0, 1. Okay, it will not give 2. So there's a 50% chance that this function here will give me a 0, 50% chance that this function here give me a 1. If it gives me a 0, I'll randomize the Y value and I'll round the X value to either 0 or 1. If the case over here is 1, I'll randomize the X value, because this is random, right? And then I'll round off the Y value to either 0 or 1. So this will give me any point along the edge of the camera as shown inside this wonderful paint program. So that's about all for the spawn manager. We have a couple of functions as well. We have a function that checks whether a certain transform is within the camera boundaries. This is be used by other scripts later on to check whether something is within the camera. And we also have a function here called reset. This just basically helps us to set the reference camera whenever we add the spawn manager. So if we add a spawn manager, notice the camera is always set. This is because the reset function here is setting the reference camera over here. So that's about it for the spawn manager. So later on, we're gonna make a few modifications to the enemy stats script as well. So to respond to your question, Gentleman Gaming, this will work for any resolution, yes, because now we are tying the spawns to the camera itself instead of having to manually place the spawn points, right? Spawn points are easier to code, but you know, in the long run, it's a little bit harder to use, right? I think that's something that you realize as well. Okay, so the next thing we want to do after we get the enemy spawning system up, okay, later on we will test it out. The enemy spawning system. Okay, let's also update the enemy stats as well. Okay, otherwise the spawn system will not work. Okay, one thing that interferes with the way that one thing on the enemy stats that interferes with the way the spawn system works is if you look at the enemy stats script, right? There is a little piece of code. Let me just refer to this one. There is a little piece of code over here that basically resets the enemy whenever it moves out of the camera. Okay, so over here under update, it just compares the positions between the player and the enemy, and if it's greater than a despawn distance, it will call return enemy over here. And this return enemy over here will teleport it back so that it's closer to the player. It's 20 units away from the player. Oh, sorry, if you move away from the enemy too much, it will respawn the enemy back at one of the spawn points over here. This is what it does, right? So if you look at the scene that we have, there are a bunch of spawn points. If you move too far away from an enemy, it will respawn back at the spawn point over here. Okay, which is a feature that Vampire Survivors has to always keep you under pressure, right? Okay, but because we've changed the way that the spawning works, we cannot use the code here anymore. So let's go over to enemy stats and then let's remove the old despawn and respawn system. Alright, so I'm just gonna remove the despawn system variable, and I'm also gonna remove the update function over here because this is what's responsible for moving the enemy back closer to the player, and I'm also going to remove the return enemy function, which is used by the update function previously to move the enemy back. And I'm also going to remove under on destroy here this code here that refers to the enemy spawner, because we are no longer using the enemy spawner component, right? We are disabling that and we are using the spawn manager instead. So just a couple of scripts that you want to remove. Okay, it's all highlighted in the blog article as well. Okay, so all the respawning, the despawning and respawning script to be moved to EnemyMovement. So we are not just going to move them over to the EnemyMovement script. We are also going to introduce a little bit more complexity to the EnemyMovement script. Let me just copy and paste the script over here, and then I'll show you how the new component looks like, and then we'll go through the codes. So let's move over to player movement. Let's open the script up, and I'm going to copy and paste the properties. One thing that I think my script is missing something. Just give me a moment. We have a default move speed 5 over here. Okay, I'm gonna have to modify the enemy movement script here because it's not the most updated version. We're just missing a line of code actually. Let me just add this line of code here, and then we can continue with the recording. So the move function is different with the project files that I've shared online. So let's just replace this section over here. Oh, my bad. Because, sorry, I confused myself because I was looking at the player movement script. I was wondering why it's so different. Okay, looking at the wrong script. So silly of me. Okay, I'm supposed to be looking at enemy movement script, right? So let's head on back to our article and let's make the modifications to our enemy movement script. Okay, so what we are going to do with the enemy movement script is we are going to move the functionality of respawning the enemy over to the enemy movement script instead. So these are the changes that we are going to make. But before I show you the changes, let me just update my script in my project and show you the component for the enemy movement script. So under enemies over here, I have the bat, and the bat has the enemy movement component. So what I'm adding to the enemy movement script is basically a new property here called out of frame action. So previously by default, right, whenever you move too far away from an enemy, it will always respawn at one of the spawn points over here. So this option is represented by a respawn at edge, right? So then if you respawn at edge, what this means is that if the enemy is moved out of the camera, it's just going to respawn back at the edge of the camera. But we also want to introduce a couple of other options. We want there to be no out of frame option. So for certain enemies, like for example the flower wall that we spawn, right? If you move far away from the flower wall, it's not going to follow you. It's just going to stay there so that when you come back, it's still going to be there. Okay, so it works a little different from the other enemies that we have. There are also enemies that we might want to despawn when you move out of the camera. Okay, so these are the three options I thought of. Okay, as we think of more enemy behaviors, we can add more out of frame actions later on. But right now it's either respawn at edge, which respawns at the edge of the camera, none, which means that it doesn't respawn at all, or despawn, which means that if you move too far, if you move the enemy out of the camera, then it's just gonna destroy itself. Okay, so we have three options over here, and respawn at edge is going to be the option that replicates the one that we had with the enemy stats functionality that we just deleted. Okay, so the enemy movement script, basically what we did was we moved. Okay, let's look at the changes over here, right? So we just did a couple of things. Okay, we just basically moved the move function, which was inside update. We moved it to its own function over here. All right, so the enemy basically calls the move function every frame to basically do the same thing that we have here. Okay, so basically in every frame we want to move the enemy closer to the player with the move function, and then we want to do something called handle out of frame action. Okay, these are the main changes to the enemy movement script. So handle out of frame action basically checks whether your out of frame action is none, respawn at edge, or despawn. Okay, this out of frame action here is actually declared inside the enemy movement script, and is declared inside the enemy movement script under a new enumeration called out of frame action, which has three options: none, respawn at edge, and despawn. And then after that we just declare out of frame action variable and then set the default value to respawn at edge. This is why when we have an enemy movement script over here, by default, if you add a new enemy movement script, right, it's always going to default to respawn at edge. This is because in the script we set the out of frame action as the default. So by having this enumeration over here, it allows us to basically play around with the variables over here. So if there is no out of frame action, then we do nothing. If it respawns at edge, then we will go to the spawn manager and generate a new position and then put the enemy in that position. Okay, otherwise if the out of frame action is despawn, then we will destroy the game object. But before we destroy the game object, we want to check if the game object spawns out of frame. Okay, why is this? This is because if you look at Vampire Survivors, right? Let me show you some examples. In Vampire Survivors, okay, you'll run into mobs that look like this, where there are swarms that just fly across you. And these swarms do not track the player. So what happens is that when these swarms leave the map, then you will want the swarm to despawn themselves, right? Just to save memory, right? Otherwise, the swarm will be just flying somewhere off the map, and they'll just be wasting resources on your computer. So we want enemies that fly in a straight line to disappear when they fly off the map. Okay, that's something that will help to optimize our game. But because these mobs, notice they also spawn outside of the map. So if you look at the bats over here, right, it's a swarm of bats, they spawn outside of the map. So the first time they spawn outside of the map, they are going to register as off camera. So we want to make sure that when they first spawn, even if they are outside of the camera, they do not despawn instantly. They only despawn when they come into the camera once and then fly out of the camera. And this is why we have a little variable over here under enemy movement, right? We have this variable over here that checks if they are spawned out of the frame. Okay, so when the enemy first spawns, we will check whether it's within the boundaries. If it's not within the boundaries, then it's considered to be spawned out of frame. So when enemy is spawned out of frame, this will be false until it comes into the frame. Okay, so under handle out of frame action over here, these actions only happen if we are within the boundaries, right? Okay, so once the give me a moment, let me test this out and see whether this works actually, because I don't think spawn out of frame is set to, right? Spawn out of frame. Handle the enemy when it is out of frame. If spawn manager is within boundaries, okay, so I think my code here is wrong. Let me just test this out, because this should be, if it's not within the boundaries, then we run the out of frame action, right? Okay, so my spawn manager should be working now and should be spawning enemies. So the reason why there are so many enemies is because the spawn manager is set up to spawn many enemies. Okay, there's starting count of like 25, which is a lot of them. Yeah, which is why it starts off with many enemies. And then 4 to 5 enemies that spawn every 1 to 2 seconds. Okay, so over here I have a little mistake here. This should be spawn managers within boundaries is false. This means that if the enemy is not within the boundaries, then we will do the out of frame action. Okay, so let me just modify the script a little bit. Just give me some time to change this. It should be false. And this should update the script over here. Okay, so this is the updated script. So if the enemy is not within the boundaries, then we will perform the out of frame action. Otherwise, if it is within the boundaries, then we can consider that the enemy has been seen by the camera once. Okay, once it has been seen by the camera, then we will set the spawn out of frame action to be false. And then once that is done, you will see that your mobs, enemies that are spawned outside of the map, right? Let me just place an enemy outside of the map, and you will see that it will not despawn itself until after it appears. Okay, so let me just maybe put a red bat in the map. Look at that, when we delete the bat, it spawns a gem. That's quite adorable. Let me just put a bat outside the map. A red bat, okay, so that we know that this bat comes from outside, and we're gonna set the out of frame action to be despawn. But what we want to do is we want the bat to appear first before it can get despawned. So the first time that it appears to us, the first time that it spawns, it will not despawn instantly. Let me make this bat blue, maybe then it's more obvious, or like purple or something. Okay, green bat. Okay, green bat will make it obvious that this is our bat. So we want the bat to be able to appear on frame at least once first before it despawns itself. So now, see that when I move it out of the camera, it despawns itself. So this is how the spawn out of frame works. Okay, we want the bat to at least be able to appear once, even if it's set to despawn. Otherwise, there's no point, right? You spawn enemy outside the map, instantly it despawns itself. Defeats its purpose. So the other changes to the enemy movement script are basically that we have made a lot of the properties on the enemy movement script protected. Okay, the reason we make it protected is because later on we're gonna subclass enemy movement. We're gonna have different enemies that move in different ways. And then when that happens, right? When that happens, we will have to subclass the enemy movement script. So by making these properties protected, we are allowing the subclasses later on that we're gonna create to be able to access these variables as well. So then we also make some of the functions protected and virtual. Again, this is to allow subclasses to access them. Virtual is to make it so that we can override the functions later on using subclasses. So later on, we're gonna create a script called ChargingEnemyMovement to create enemies that will just charge towards the player but fly out of the map after that. So it's gonna move a little bit different. And then I'm gonna show you how you can override certain functions over here to change the behavior of the enemy movement without having to write an entirely new script. The other thing, besides making everything protected or public, is we also change the way that the player is found. Okay, so this is in preparation of making our game multiplayer compatible. So with the script that we have over here, what we are doing is we're just finding the first player in the game. Okay, so we don't want to always find the first player, because it's possible if it's a multiplayer game that there are multiple players, and we want every enemy that is spawned to not just come after the first player. We also want the enemy to come after the second player or the third player and so on. So instead of getting always the first player, we are just getting all the players and then randomly selecting one of the players on the map. So then if there is only one player, it's always still going to get the first player, but then if there's more than one player, it's going to randomly pick one of the players. Alright, and these are the updates we've made to the enemy movement script. Main thing again is the out of frame action that we have over here on the enemy movement script, which is on the bed here. Yeah, so then we can select how the enemy behaves when it's outside of the camera. Okay, so you can read the blog to also run through what I've just explained. And the next thing you want to do is, okay, let me just show you what happened with the bat over here. Okay, so I'm just gonna disable the enemy spawner, and I'm just gonna let the bat come into the screen. Okay, and I'm gonna move out of the screen so that the bat despawns itself. I think the lightning ring killed the bat before it could despawn itself. Let me try that again. Let me make sure this is set to despawn first. And I'm gonna despawn the enemy for you and show you what's going on, right? So that you know what bug we are trying to fix next. So when I despawn the enemy, there are times when it will spawn a gem. Okay, there's 50% chance of it spawning a gem, right? Despawn that. Okay, it's not happening. Let me try that again. See that? So sometimes when you despawn enemies like that, this spawns a gem, and we don't want that to happen. We only want drops to happen when you kill the enemy, right? Doesn't make sense if you despawn an enemy, then it spawns a gem. So what we're gonna do here is we're gonna make a small modification to the drop rate manager as well, because the spawns are actually given to us by the drop rate manager that's right here. So here we have a drops array here that determines what items that will drop, right? So let's go over to the drop rate manager, and then let's add another variable that we can use to control whether the drop rate or the drops happen. Okay, so under drop rate manager over here, I will just add a new public boolean active, and the value by default will be false. So when the drop rate manager is not active, what we are not going to do is we are not going to allow the drop rate manager to spawn any drops. So the modification is right here. So if the drop rate manager is not active, then we are going to just do a return. So this prevents spawn from happening if it's inactive. So these two changes over here, by adding a new variable over here and adding this check over here to make sure that nothing is spawned if the drop rate manager is inactive. This allows us to, in every enemy itself, right, we can set the drop rate manager here to be this active to be false, like that. So if we set this to false, even if you set the drop rate here to 100, okay, you will see that the enemy will never spawn an item. See that? So by adding this gives us a way to deactivate the drop rate manager. So we're gonna disable the drop rate manager by default unless you want enemies to always be spawning objects. This should be inactive. And what we want to do then is let's go over to enemy stats, and we want to basically add a new line in a couple of lines in the kill function that activates the drop rate manager. So this will look something like that. Under enemy stats over here, we have the kill function, and then we will just try to search for a drop rate manager component, and then if there is a drop rate manager component, we will set the drop rate manager to be active. So then what this does for us is that it makes it so that enemies will only drop items if they are killed. They will not drop items if you despawn them or you try to remove them from the map in a certain way. So if I kill this guy, you will see that he will spawn a gem. Alright, but if I despawn him, or as we code more and more functionalities into the game, you will find that you have to destroy game objects without killing them a whole lot of times. Okay, so if they are not removed by killing, then they will not spawn any drops. This is a very important change that we have to make to the game. Otherwise, later on, if we have mobs, if we have flower walls, you will find that the mob will fly across the screen and then they will disappear, and then when they disappear, they will leave a whole bunch of gems. Okay, you don't want that to happen. That is why we are creating this way for us to disable the drop rate manager at certain times. So with that being said, that's most of the changes that we are going to be making. So then our spawn manager, by now, by making all of these changes, you will find that your spawn manager should already be working. So if I were to reactivate the spawn manager, and let me just show you this in action, I'm just gonna create a couple of new enemies, and I will also show you how you can what is the most efficient way that you can do that. Okay, if you scroll all the way to the bottom of the article, or if you're watching this video, then you will have to refer to the links below. You will find links to 2 spreadsheets. Okay, we have a spreadsheet here for a carnivorous plant and some other enemies, and then we also have a spreadsheet here for zombies and skeletons. Okay, so I'm gonna use these 2 spreadsheets here to create a couple of new enemies, and then we can just kind of play around with the spawns for these enemies. So I'm just gonna create the zombie and skeletons first. So how I would go about doing that is I will just import these guys into the project, into the art folder, right? And then from there I will have to slice the sprites. So the zombies are here, and let's go to the sprite editor. How many items are there? We have 4 rows and 9 columns, right? So let's try a slice. To slice the sprite, you will need to set this to multiple, and then sprite editor, and grid by cell count, 9 columns and 4 rows. This will give me sprites that are quite perfectly sliced like this. Okay, so I'm just gonna do apply here, and then this will give me a whole bunch of sprite sheets for the zombies and for the skeleton. Okay, so for me to create new enemies over here, I'm just gonna, because we already have the bed prefabs, right? I am going to, okay, before that, one more thing. I need to check for the size of the zombie and the skeleton, just to make sure that they're the right size, because right now when I move them into the map, they're very small. Okay, so the natural thing to do is to increase the scale, but I'm not going to do that. What I'm going to do instead is go to the zombie skeleton, the sprite sheet over here, and decrease the pixels per unit. This will increase the size of the zombie. So I want to find a value that's appropriate, maybe 35 would be good. And if you look at the zombie itself, you will see the edges are blurred, but this is pixel art. So what I want to do is turn off filter mode as well to make the pixels sharper. Alright, so you gotta make sure your pixels per unit are set to the correct size so that the zombie appears the right size as you want it. Okay, you don't want to play around with the scale. Try avoiding doing this because the scale should be 1, because you can play around with the pixels per unit. So there's no need for you to play with the scale over here. Alright, so then you also want to again set the filter mode to point so that the pixels show up properly. So once you do that, try taking out the skeleton onto the scene as well and make sure that it's the correct size. It's the size that you want, and then once that's done, you can just start creating prefabs for them. Okay, so what I like to do is I like to just use the bed, and I like to unpack the bed prefab. And from there, I will just start replacing the sprites with the sprite that I want. So the sprite that I want is I want a new zombie, right? So I'm just gonna place a zombie here. And then, of course, I've got to adjust the box collider of the zombie. So what I prefer to do often is I would just prefer to set the values on my own. So the size here will be, say, 0.5. And the height here will be, let's say, a value of 1. And then here I can just offset square like that. Okay, oftentimes I prefer to just manually set the values myself because I think this gives me more control over the whole thing, and the values just look cleaner and nicer as well, right? Okay, so once you change the values over here, you can give the zombie a different set of stats as well, which we will get to later. And then the drop rate is the same thing. Okay, we're gonna get to the stats later because we have to modify the stats briefly later on. Okay, so once everything is set up, we also need to go to the animator. And what I'm going to do here is you'll see that the bed has an animator controller over here. And we can just make a duplicate of this animator controller because their logic is the same, right? And basically, the bed is just going to play one single animation over here, right? So what I'm going to do here is I'm just going to create a new animator override controller. This is quite similar to the part 16. There's a part 15.5. If I'm not wrong, that I created. that shows you how to create different animations and different sprites for your different characters, right? So over here, we're going to use a similar concept because the controller, the animator logic for the enemies are very similar. What I'm going to do is just create a new animator override controller. I'm going to call this zombie animator. And then from there, I will just put the bad sprite sheet over here, and this will prompt me to override the movement with a new animation clip. So once I have that, let me just assign this zombie animator to my zombie character. Where's my zombie character? Right here. Let me call this zombie as well, so I can easily find him. And under the animator over here, let me just replace this with the zombie animator. And then when I go to the animation window, now I'm able to modify the animation of the zombie. Right now, if the zombie moves, it's gonna turn into a bat. I don't want that. Instead, I want to create a new animation like this and call this zombie move, right? Zombie move will be attached to the zombie animator. And then what this means is that now when the zombie is moving, he is going to be playing his own animation. Okay, so then last thing I want to do is to go to animation over here and then just assign the animation sprites for the zombie. Yeah, so the zombie just has a 2-frame sprite, right? So then when I put the 2 movement sprite, the zombie is just gonna move like that. Okay, so the sample rate will control how fast the animation happens. And yeah, that's about it. So that gets my that gets my zombie animated. Okay, so one thing you'll notice about enemies, right? Let me just prefab this zombie over here first. Why is the zombie not animating? This is strange. Let me see what I missed out, because I probably missed out something to cause the zombie to not animate. Zombie is here. Where is the animator? Animator should be active, right? I forgot to activate the animator. It's probably why the zombie is not animating. So the zombie is not animating for some reason. Find out why. Oh, okay. Don't forget this. Don't forget to set loop time over here, right? So because the animation loops itself, so you gotta make sure to set loop time over here so that the animation will keep repeating itself. Otherwise, it's just gonna play once and stop. And now the zombie is moving. Alright, it's animating. Okay, so you will notice that you can more or less prefab the zombie now, and then you can go through the same process to create the skeleton as well, or for any other enemy that you want to have in the game as well. Alright. But one problem that we have over here is that we will have to create a new scriptable object for the enemy as well. So if you look at the bats, right, even though the zombie itself has a current health, current speed, and current damage, the stats are actually stored inside a scriptable object over here, bad enemy and red bad enemy. Okay, which is something I don't like because they are already stored as prefabs, right? So prefabs by themselves can already store information. See that? So I can directly just store the stats inside enemy stats. I don't have to create a new scriptable object. Right? Doesn't make sense, right? But over here we have a scriptable object. So what I'm gonna do is I'm just gonna remove the reliance on scriptable objects for my enemy stats, which means I'm gonna go to enemy stats over here. I'm going to remove the enemy scriptable object script over here. Okay, this is in the blog as well, yeah? This is documented in the blog under part 5, which is right here. Okay, so we remove the enemy scriptable object, and we remove the setting of the stats via the enemy scriptable object. Again, This is in line with us only putting variables that we have to set inside the component itself, right? There's no point putting these variables here if it's gonna be set by enemy data. All right, so let's remove the enemy data reliance here, and then let's also remove the setting of the stats using enemy data. I don't think there's any other modifications, right? Everything else is the same. So when we remove this, what this allows us to do now is that you will find that all our prefabs, we can set the stats directly. So our bets, for example, right now, we will now have to set the stats of the bet inside the prefab itself. So I forgot the stats. Let me just have a look at those stats again. 1, 10, and 3, 1.5, 10, and 3. So the bet stats will be inside the prefab itself, 1, 10, and 3. And then the red bet will be 1.5. Let's give the red bet a bit more health. Yeah, 16 and maybe 5. Okay, so the zombie, maybe you want to give it even more health, but then like very little speed. This will differentiate the enemies a little bit, right? So all the stats that you want for the enemies, you have to set them inside enemy stats now, inside the prefab. Okay, there's no point for us to set the stats, for us to set everything in the prefab, and then for us to set the stats inside somewhere else, right? Inside the EnemyScriptableObject. It's a very disjointed way of doing things and it makes no sense. But now because we have removed the link from the scriptable objects in the enemy prefabs, we can just go ahead and delete the enemy scriptable objects. And then we can also delete the enemy scriptable object scripts, which are right here, enemy scriptable object. Let's just remove the script right here. Okay, so now we have enemies set up in a more efficient way. All of their stats are set inside their prefabs themselves. Okay, so let me maybe just go through, or rather let me just create one more enemy since we have the skeletons as well, right? Let me just quickly create the skeletons as well. So it's gonna be the same process where we replace the sprite with a skeleton sprite. And let me just delete the zombie. Okay, I unpack the prefab, replace it with a skeleton sprite, and let me just set the collider for it as well properly. And then the next thing we will do, same thing, right? We set the animator for it. Animator will be, it will have a new animator override controller, and then this will be called skeleton animator. And the skeleton animator will be using the bet as a default, and then once we have the animator controller, we can apply this to the animator for the skeleton right here, and afterwards we can go to the animator window and then replace the frames here with the frames of our skeleton. So let me just make sure that I go to the skeleton animator here and make sure that I create a new animation clip. This will be called skeleton move. And skeleton move will be assigned to the skeleton animator like that. This is again an animator override controller. So now under animation here, let me just activate the animator and make sure skeleton move has loop time checked, because this animation will loop, right? Otherwise it will play once and it will stop. Okay, so go to animation now, and then we can assign, let's set the frame rate to be, say, 8 frames per second. Move the animation up, and then find the sprites for the skeleton. Drop them here, and we should be ready to move. So why can't I drop them here? Select the skeleton, drop 1 frame here, and drop 1 more frame here. And then this will give the skeleton an animation. Alright, so then once that's done, you will see the skeleton should be able to animate itself as well. Yeah, so now we have skeletons, we have zombies, and we can create different waves. So for the skeleton, I would like to set the stats of the skeleton to be slightly different as well. I want the skeleton to be faster, but have less health, around the same damage as the zombie, and then we can prefab the skeleton as well here. So now you see all the enemies are neatly prefabbed, and then once they are prefabbed, we can create wave data for them, right? So we can have a bat wave, and then we can have a skeleton wave. This skeleton wave will contain just skeletons, right? And then maybe 3 to 4. Okay, so the main thing for the wave is just set how many enemies you want to spawn, how frequently, maybe 1.5 seconds, 3 to 4 skeletons every time, and then let's do a zombie wave as well. Zombie wave. And then I can say, make it so that the zombie wave only ends when I kill all the zombies. Alright, so duration maybe will be 10 seconds. It will spawn a whole bunch of zombies, maybe 8 to 10 every 2 to 3 seconds. So then once this is done, I can assign these waves to the spawn manager, and then you will see that this will cause the waves to change over time. I'll just shorten the duration of the wave to 10 seconds each. Yeah, so that we can see the waves progress a lot faster. So then what's going to happen now is that the game is going to start with bats. And then after a while, we're going to get zombies, and then we're going to get skeletons. And because I've buffed the enemies, they're a little bit more difficult to kill, which makes the game more fun, right? It's more challenging now for us to get around and get all the gems and everything that we want. Oh, the game is a lot more challenging now that I can't one-hit everything. And it's so hard to get experience as well. Need better weapons. So you see, we kind of have a much more interesting game here, right? Just because we have a whole bunch of mechanics that have been set up already. So then after the first wave ends, then we will get the second wave, which is just zombies, right? See that? And then for the zombies, right, because we've set the wave to end only when total spawns. Okay, I set this up the wrong way. Let me just retry this. This shouldn't be reach total spawns. Or rather, if this is reach total spawns, then what I need to do is to reduce the number here to say, okay, let's set this to duration actually. Then we can leave this at this default value of like a very high number. Okay, so let me just set this to wave duration, but then must kill all. Okay, so if I check must kill all over here, you will notice that for the zombies, I have to kill everything for the wave to proceed. So again, we start with the bats first. The game is so much more fun now because it's harder. It's harder to get through everything. It means they're harder to kill because they have more health. So then you'll see after 10 seconds, then zombies will start spawning. Did I set the must kill all? Oh, I set must kill all on the bats. That's why the zombies are not spawning right away. But if I uncheck this, then the zombies should spawn. Yeah, so it depends on how you set up the waves. This will change the behavior of the waves. So previously, because I set must kill all to be true on the bats, then the zombies will not spawn until the bats are all killed. But once I uncheck that, the zombies right away spawn. So zombies are slower kind of enemy. And I mean, there's a lot of them, but they move slower. So then for the zombies, for the next wave to spawn, I have to kill everything. So let me just kill all of them. Oh, there's a lot of them. Huh? It's like they're spawning forever, man. Why are they not stopping? The exit condition is wave duration, right? Wave duration is 10 seconds. This is like a nightmare, man. The zombies keep coming. And I'm trying to figure out why. It's probably because I coded something wrong then. Because the duration is definitely over. Let me look at the spawn manager and try debugging it. Current wave duration is 141 seconds. And we are still spawning enemies. Which means that there is something wrong with the... Let me try this again. There's something wrong with the code. So after 10 seconds, you will see the zombie spawning because the bats will only be around for 10 seconds. Zombies should only also be around for 10 seconds. Unless I'm missing something. So the current wave duration is 10. It should stop after 10. So the zombies will spawn forever. Which means I'm missing some... Oh! This wave duration is correct, no? What's the difference between the zombie wave and the bat wave? Starting count, duration is 10. I think that means that we just have to fix a bug with the spawn manager right here. The spawn manager, probably something is wrong here and it's has wave ended. I think we're missing this. Let's do an else. Then true. Okay, looks like we have to do some debugging. Fix a bug with the zombies spawning forever. I'm just gonna go and make myself a cup of tea first. This new spawner is pretty nice, right? It makes the whole game just feel more happening. I'm gonna be right back. But I figured out the bug while I was making my tea. So let me just run through that bug. The bug is actually with the can spawn function. So basically what happens is that the zombies will spawn forever because of the way that the configurations here have been set up. So by right, after 10 seconds there should be no more zombies spawning, and then we will have to kill all zombies for everything to move forward, right? But after 10 seconds there shouldn't be any more zombies spawning. The problem here is that under can spawn, right, I'm missing some codes to check that the duration is not over the. So what I'm saying is, let me just write the code out for you to show you. I'm just missing one more check here for current wave duration. If it's greater than the duration of the spawner, then you shouldn't be able to spawn anything as well. So I'm missing this one line to check for the duration, because once we exceed 10 seconds, then no more enemies should spawn. So let me just update the article with this change as well. This should be under spawn manager. So we have a great thing going there, and later on when we start adding the events that allow us to spawn the flower wall and all that stuff, it's gonna get even cooler, man. So yeah, the best is yet to come. So let me just add one more line here into can spawn. And maybe I'll just add some comments as well. Don't spawn anymore if it. And otherwise, we also don't spawn if we exceeded the net spawns for the wave. And don't spawn as well if we exceeded the wave's duration. It's just a little oversight, you know, it happens. But with this fix now, the zombies should not be spawning forever anymore. And let me just update this in my own code base as well, so that I can just share the codes with you all later for the project files. So comments are important, right? Comments make the code easy to read. I don't explain everything in my code, so it's so that's why the comments are even more important, because you will have to read my comments, right? If you want to understand everything that's going on, I'm just explaining the big picture to you all. Yeah, 100%. Like I knew that a cup of tea was what I needed to see what the problem was. Let's see if this actually fixes the problem. Let's have a look at the level again. So now I've got a couple of waves. I have some bats spawning for 10 seconds. After 10 seconds, the zombies should start spawning, and for the zombies, I have to kill all of them for the waves to advance. So let me just get some leveling up going, because having a garlic is so difficult to get through the level with just a piece of garlic. Now with a whip, it's a lot easier. So now the zombies don't spawn forever anymore, and I just gotta kill all of them here. And we should be able to progress to the next wave. I'm so glad I spotted this bug before I released the video, because otherwise it's just gonna make everything so much more complex, you know, because I have to release another video to address the bugs. So now the zombies are gone and the skeletons will spawn. So because of these extra properties that you have on the wave data here, you have a lot more control over when the spawns will happen and how the spawns will happen. And you know, we have exit conditions as well, and you know, all this Just gives you a lot more control. So the skeletons will spawn for 10 seconds as well. And what you will find is that after all the enemies have spawned, the spawn manager will deactivate itself. See that? So then this gives us a way to configure the level manager so that we can make the level manager just end the game when all the spawns are done. So perhaps I will just add this to the video later on because I haven't coded this feature. So we have the spawn manager more or less working. The last thing to do is, before we move on to the event manager, is just to get the game manager to be able to end the game when the spawns finish. Okay, maybe I'll just add this to the new section later on. Okay, let's just move on first. Now we have all the spawns working, right? So we've also made the enemies not dependent on enemy scriptable objects. Hi Ghana Place, thanks for popping in. Just recording content for part 21 of the video. So after this is done, then we'll cut up the video and then compress it to like hopefully less than an hour, and we'll release the video. I hope you are following the series and I hope you're enjoying it. So next part of the content is going to be adding a new charging enemy movement. Thanks for the sub. So next part is adding a new charging enemy movement, and what this is for is, notice that for now we have enemies, right? All enemies are following our character like this. Yeah, so no matter where you go, the enemies will track you. But we want to have special spots, right? Like we want to have flower walls, and we also want to have mobs like these. You know, in the game you will find that sometimes you have mobs or enemies just flying past, right? So for these kinds of enemies, right, you will notice that they do not track the player. They just fly in whatever direction they're moving in, right? See that? So you can dodge them, they're not going to track you. So for that to happen, we are going to have to create a new script, because this enemy moves different, right? So we will create a new charging enemy movement script. We just talked about how we made the enemy movement script overridable, right? We made a whole bunch of the functions protected, and we made a whole bunch of them virtual as well. This is because we want to override them in a subclass. So what we're going to do is create a charging enemy movement script that's going to be similar to our regular enemy movement in many ways. It just differs in one small aspect. So in the enemy folder, I will just create a new charging enemy script, charging enemy movement. So the most important thing about charging enemy movement is that it does not inherit from mono behavior, rather inherits from enemy movement. Yeah, just like our weapons and items and passives, right? They're all related. So this charging enemy movement is gonna work by overriding the move function. Why? Because it's just gonna move in a fixed direction. Alright, so how this is gonna work is, I'm just gonna, in the start function, calculate where the charge direction is gonna be. So when the enemy first spawns, right, it will move towards the player. It's gonna determine where it's gonna move, and it's gonna be towards the player. But once this is set, it never changes again. So then every time it moves, it just moves in the direction that is set in when it first spawns. So what happens here is that once I create this charging enemy movement script, I am able to attach it to a different enemy prefab. Okay, so with this charging enemy script here, I will move, I will create a new prefab for my bad enemy. So I'm gonna, if you notice the mobs, right, they move faster. See that? The mobs, they move, the bats in the mob, they move faster than the regular bats. So what I'm gonna do here is I'm gonna create a new variant of this bat by going right clicking on them, going to create, and then prefab variant, and this is gonna be called bat mob. And this mob here, right, I'm gonna increase the move speed to something ridiculous like 4 or maybe 5. Has to be faster than the player, right? But it's not going to use enemy movement. It's instead going to use charging enemy movement. So I'm going to remove this, and then add enemy movement over here like this. Alright. So then with this, we also want to set the movement here to despawn, so that when it moves, when it charges over across the player and it goes out of the map, it's just gonna disappear. Alright. And of course the drop manager should be inactive, alright? Otherwise when they despawn, they're gonna drop a bunch of blue gems. Let me set the drop rate here back to 50 for all of the enemies. So I'm just gonna demonstrate this for you. I'm just gonna drop a whole bunch of mobs. And what they're gonna do is just fly towards the player because they all have charging enemy movement, right? Or did I do it wrong? This is supposed to be charging enemy movement, right? Added the wrong script. Sorry, charging enemy movement, not enemy movement. So if I add a charging enemy movement here, and I assign all of these bats here, they're just gonna charge across the player. If they are set up correctly. Oh, they just despawn, huh? Charging enemy movement, sorry, I've gotta make the bat here despawn. Sorry, not despawn. Oh yeah, despawn, sorry. Okay. If it's respawn at edge, they're gonna basically spawn and they're gonna be placed at the edge, which is not what we want. So let me just show this to you. This should be despawn. Sorry, it's not respawn at edge. Oh, I don't know if the camera can see this. Let me just show this component to you, because it's all the way at the bottom, right? Let me just show the prefab setting here. So what we want to do is add this charging enemy movement, and then remove the enemy movement script. Set the out of frame action here to despawn. Right? I realized my face was covering the component just now. So what this happens is that you get a mob like that. That just flies towards the player. See that? So then later on we'll write a script to spawn these mobs randomly, like across the map. But now we just want to have a prefab for the bat mob. And if you want to have different mobs, like mobs have to be configured differently just because they move faster. That's why I'm having a different prefab, and they have a different movement script as well. So later on we'll create the flower wall as well. The flower wall is gonna be a little bit different. So let's we've done the charging enemy script. Okay, so the next thing you want to do, right, is to add something called the event manager. The event manager is for managing events in Vampire Survivors, because if you look at Vampire Survivors, right, there are actually two spawn systems. There's one spawn system that is the default one that just constantly spawns enemies around you, and then there is a spawn system that spawns events every 30 seconds. Okay, so this is what the event manager is going to do. It's going to randomly pick an event and fire the event every 30 seconds. But for that to happen, we will first have to create a new scriptable object, and I'm going to call this event data. It's going to be abstract as well, and I'm going to explain how this works later on. Okay, we're going to just set up a mob event data that will spawn mobs of bats every 30 seconds in the game. So let me just go to the scripts over here, and under spawning, I'm gonna create a new script here, and it's called event data. Event data is gonna inherit from spawn data, which is the base class for wave data as well. Okay, so if you recall, our wave data script over here inherits from spawn data, which basically stores information about possible spawn prefabs, how often things spawn, and all that stuff. Okay, event data is going to inherit from that because the events are going to function in a similar way as well. Okay, so we add event data into our project, and the first thing you realize is that there's a red underline here called get elapsed time, and there's an error over here. The error over here happens because our event data does a couple of things which I will go through later on, but for now let's just fix this error over here first. Okay, so what this script needs is it needs to get from the game manager how much time has passed since the game has started running. Okay, so I'm gonna have to go over to the game manager script and just add a new function here, because the game manager script already has a variable called stopwatch time. This tracks how long the game has been running. So I'm just gonna add a new function right above right below choosing upgrade. right here. And this function is going to just return a float get elapsed time. And this will just return stopwatch. So this just allows the event to check how long the game has been running. Because in the event we have a variable called active after. And what this does is that this event, if you have an active after value, then this event is only capable of firing after a certain time. So you'll notice in Vampire Survivors, some of the events don't happen until after you play the game for a while, right? For example, the flower wall will spawn only like 3 minutes or so into the game. They will not start right away. And this is what the active after variable is useful for. So the next thing we want to do also is the event data is actually an abstract class. So the next thing we will want to do is we will want to also add a mob event like this. Okay, maybe let's add the event manager first. Okay, let's add the event manager first. And then I'll explain everything all together. So the event manager is going to be attached. Event manager script. Event manager is going to be attached to the enemy spawner. So your enemy spawner is going to have the following scripts. It's going to have the spawn manager and the event manager. The event manager also takes events just like the data over here, but then we haven't got any events to assign here at the moment. So the event manager only has a couple of variables. It has a first trigger delay. This controls when is the first event that fires. So by default, what I've done here is I've set it so that only after 3 minutes will events start firing. Okay, after that, then events will fire every 30 seconds. So you set these two values over here, and then you just assign a bunch of events, and then these events will happen every 30 seconds. Alright, so this will work together with the spawn manager to create a whole bunch of enemies on the screen. So once we have the event manager set up, then let's create a mob event, and then from there I'll explain how everything works. Or maybe let me just explain how the event manager works first. Okay, how the event manager works is it's similar to the spawn manager because most of the logic is inside update. And what it's gonna do is it basically just tracks the cooldown, and then every time the cooldown hits 0, it will try to create a new event. It will select a random event. So then we have a get random event function over here, and then inside here we will pick out all the possible events, and then we will pick out all the possible events, and then from there we will select one random event inside over here. Okay, so this is a little different from the default way that we use to randomly select something, because in each of the events that we have, right, we actually have a active after. Maybe let me just create an event with you, and then after that I can explain a lot easier. Okay, so let's just go to the mob event data over here, and let's create a new event data. Then we can start creating some events and we can see how it works. Alright, so the mob event data is gonna be a class that will okay, I noticed I missed out something here. Let me just the code here is wrong, so I've got to update the code here. So what I want here is basically, let's see, the event data here, it should only have a single function like that. Sorry, single parameter. My code was wrong, so let me just implement the mob event data. So once I get the mob event data going, you should see that you will now be able to create a new scriptable object type. Let me just create a new folder under the scriptable objects wave data folder, and let's call this folder mobs. And in here I'm just going to create the bad mobs. So create, and then there will be an event data here, mob, and then this will be bad mob. Notice also that previously we had an extra option over here, right? That was missing because we used to have enemy scriptable objects, and we have removed the enemy scriptable object. So now there's only our all of our new weapon data types. Anyway, so we have a bad mob over here, and then you will see that the mob has a set of different properties from the wave data. So the wave data, there's a spot that there are the spawn data properties which are here, which control again how long the event lasts. So maybe if I want the mobs to only run for 10 seconds, what I'll do is I'll set duration to 10. This will cause the bad mob to only stay around for 10 seconds, okay? And what I want to do is I want to have a large number of bats spawn every time, right? So maybe I'll set the spawns per tick from 20 to 25. And the spawn interval, maybe let's set this to 3 to 4 seconds. So this means that there's going to be anywhere between 2 to 3 mobs that will spawn because the duration is 10 seconds, right? And then there is also event data over here. This is what is defined inside the event data class over here. What's going on here is that the event data variable, or rather the event data variables, control how often the event fires. So with a probability of 1, this means that the event always fires, okay? But in the game, you will find that the luck stat actually affects. You will find that the luck stat actually affects how often events happen. Alright, so in the game, if you look at the wiki article, right, there is a section here called skipping events, which is not okay. So over here, you are able to skip events if your luck is high enough. Okay, so the event chance will be divided by total luck, and this will affect how probable the event will happen. So then you're able to set the probability of the event, the base probability, and how much luck will affect it. So if you set the probability to 1, no matter how much luck you have, the event will always happen. Otherwise, if you have probability of, let's say, 0.5 of the event happening, right, it's 50%, right? Then the luck factor is 1. This means that the more luck you have, the more the probability that the event will not happen. Okay, so there can be events that are positive and events that are negative. You can have events that spawn items as well. They don't necessarily have to be enemies, because you can spawn any kind of game object. Alright, so under possible spawn prefabs here, these are all game objects. It's possible for you to spawn items as well with this event system. Okay, so you can set certain events that are positive to always happen, and then events that are negative, you know, maybe they don't happen as often. Then you can use the luck factor to adjust the events. Active after controls how long you have to wait before the event fires. So for example, if you have a certain event that maybe only starts firing after 10 minutes, then you can set this to 600. Okay, then this will control when the event fires. Mob data over here, okay, so this mob data over here is unique to the mob event data because we're going to create a bunch of event data types later on. Like we have the ring event data that we're going to create for the flower wall later on. So this mob data over here, this controls where the mob can come from. Okay, it can come from all directions around the player, right? So this is why the possible angles here is 360. Spawn radius of 2 means that we'll draw a circle, and then all the bats will spawn within this circle. And then there is a spawn distance of 20, how far away from the player this spawns. So the spawn distance here, you may want to set this to a large number, a reasonably large number, so that it always spawns outside of the camera. Otherwise, if you set this to a too small a value, it's always going to spawn inside the camera, which is not going to be a good thing. So once you have the mob data and everything set up, I'm just going to put the bat mob inside here. And I'm going to go to the enemy spawner, and I'm just going to make the events spawn every 10 seconds, just so that you can see this stuff happening a lot more often. And what you will start finding is that the bats will start spawning. So we have like a bunch of enemies, and after 10 seconds, you will see like a mob will spawn, and then every 10 seconds subsequently you will have mobs spawning. See that? So the event, when it happens, because our event, remember that is set to be 3 to 4, and 10 seconds, right? So that means this event will last for 10 seconds. So for 10 seconds, every 3 to 4 seconds, 20 to 25 pets will spawn. So this is how the mob event will happen. And of course, right away, you see it's a lot more stuff happening on the map, right? Which makes everything a lot more fun. Okay, so different events will need different codes. So what we've done here is we've created a piece of code for the mob event data, and it bears me explaining how the event data, mob event data, and event manager works. Event manager is the least important to understand because as long as you know how to use the event data scripts to create new kinds of mobs, then you can start expanding upon this system to make the games that you want. So the event manager, let me just very quickly go through this anyway. So the event manager, basically, you just look at the update function. It tries to pick a random event every time that an event is supposed to fire, and then this get random event function will look through all the events and check whether and only pick events that are possible to happen. So for example, if you have an event that has an active after attribute that is very high, so active after 600 for example, then this event shouldn't happen, right? Just give me a moment. I think I missed out something. There is the isActive function is because just now when I said the active after the 600, the mobs shouldn't spawn actually, but the mobs are still spawning. So that means that there is a bug somewhere that I missed out. Oh no, actually it's okay. The mobs is spawning now. The mob shouldn't be spawning, right? Because the active after is here. So previously the mob didn't spawn because the probability of it spawning was 50%. So it probably missed the probability here. So active after doesn't work properly. So let me check why it's not working. Go through all the results until we find one that can be used. And random range. So we pick an event, check whether it's active. Oh, this should be possible events. Okay, my code here is a little bit wrong. Let me just modify this. Possible events, remove result. Then we change the result. This should be possible events, my bad. Possible events. Get random event. If So here I'm just making a few modifications to prevent bugs from happening, and I also have to check if events.length is less than or equals to 0, then we will have to return nothing. No events, sign, on, then get a list of all possible events. Go through all events until we find and then we pick. Doing this until we find a suitable event. Possible events, random range, count. While this is greater than 0, we set result. Okay, I think this works now. Let me test this out. So with the event being active after, let me just set this to maybe 40 seconds. So this means that the game must run for 40 seconds before I start getting bad events. If I get events anywhere before 40 seconds, then it means that the code is still not working properly. So no bad events for now. 20 seconds now, we have to wait until 40, right? Check if there are any errors. Okay, no errors. That's great. Okay, 40 seconds, there's a 50% chance of the event happening. So if there's no events, then we gotta wait for another 10 seconds. So now the events are firing. It's working. So at 60 seconds, there should be another 50% chance of the events firing. And there you go. Happen again. So one thing that you notice is that the enemies are spawning within the map, and this is because the spawn distance is not set large enough. Right, so I'm gonna have to set the bat mob to have a larger spawn distance of maybe 40, because camera is really large, right? So then we have more than 20 units. So then we have to set the spawn distance to a larger value. So perhaps we can also modify the mob event data to become smarter, so that it knows how to spawn enemies right outside of the map. So we can, I probably will release a forum post to address this. But for now, let's just play along with this. Let me just copy and paste this updated EventManager script into the article. That's here, right? That's the event data. There we go. Event manager is this one, right? Okay, so let me just go through all the scripts again. Let's go through the event manager. But more important thing again will be going through the event data and the mob event data scripts, because then you will know how to create different kinds of events for different kinds of mobs. Okay, so the event manager, how it works is that it basically, you just look at the update function, it just tracks the current cooldown similar to the spawn manager where there is a spawn timer. Here we have a current event cooldown. And once it's cooled down, we try and get random event. Random event is why we have a function specifically for that is because the events themselves, right? We don't just pick a random event, we also have to check whether the event is suitable to be fired. If there are no events, we don't return anything. So then we don't give any event if there are no events. Otherwise, we will try and find an event that is suitable. And then we will assign the event. I think there is also a possible problem over here because possible events greater than 0. Remove the result. Then we pick another random event. So it's possible that there is nothing inside here. If possible events count is greater than 0. So we have to change this part as well. So it's just a couple of logic issues with my code here that I missed out the first time. Okay, so let's continue. So get random event. It helps to pick out an event. It checks whether an event is active. What is active? Is active here. Recall for our events there is active after. So the time of the game must be more than whatever is set here. So in this case here 40 seconds before the event can fire. So the get random event is going to try to find an event that is suitable and push it out, or if there are no events, it's going to return nothing. Otherwise, if you go through all the events and then you cannot find any suitable event, you also return nothing. That's what this function basically does. So it basically gets a random event, and then basically over here, if you are able to find an event, because it's possible that you get random event and you get nothing. If there is nothing, if there is no event for you to select from. Otherwise, if there is an event, you can check if the event will happen. What this does is, if you look at the event data, there is a function over here called check if it will happen that considers the probability and your luck factor to figure out whether the event is gonna happen at this point. So the higher your luck, the lower your probability is going to be, which means that if, well, your probability should be higher, right? Otherwise, get a random number and see if we pass the probability test. I probably have to update the formula over here. It's a little bit off. But what this function does is it checks the probability, it checks your luck. And then from there, it determines whether the event will happen. So your event, if you set the probability to be less than 1, it's not guaranteed to happen, like I've mentioned. So this function here is in the scriptable object. And then after that, it fires the event, and it fires the event by creating a new event object. Okay, so over here we have a class. and the class contains the event data, the duration of the event, that how long the event has been running, and the cooldown of the event. Why? Because the event has a spawn interval, right? So every event data has a spawn interval over here. So this is tracked by this nested event class. And then every time we run an event, we will just create a new event and put it inside this running events variable that is declared here. Okay, I'm just gonna show you how this works in game itself. I'm just gonna go to the enemy spawner. I am gonna set this event to be active after 0 seconds. So right away you can see it running. I'm gonna set this to debug as well. And then over here you can see better how the event manager runs. Okay, this is a better way than going through all the scripts actually, I think. So there is an event cooldown over here. Event cooldown over here. And then when it hits 0, the event will fire. And then you will see the event will be stored here under the running events right here. And then once the running event duration finishes, the event will go away and new event will come in. So right now it's not obvious because the old event was removed and the new event is added. So let me just maybe put a bigger gap between the duration and the, let's set the duration to 5, and then you can see this a little bit clearer. So I'm just gonna go to enemy spawner again, and you will see that the events, when it fires, after it finishes firing, the event will go away. And then when the event fires again, the event will be added to the running events list. So this manages the cooldown, this manages what event is currently running. So if the event doesn't fire, it's because the event doesn't have 100% chance of firing. So it takes a little bit of time, and then when the event runs, it's gonna appear here. Again, this is when I go to debug mode, right? So this kind of shows you behind the scenes how the script runs. All players variable is just to track all the players over here. And that's about a brief summary of how the event manager works. And basically the event data is the important thing that you want to understand if you want to expand upon the events that you have. Okay, so we just created a mob event data, and for all the event data that you create, you just have to write one function, and the function is activate. So activate basically controls, right, what happens when this event fires. So when this event fires, for example, for the mob event, it's just gonna pick out a random angle from the possible angles value that you have. And then from here, it's just gonna get spawns. Get spawns, basically, what does it do? It basically gets all the possible spawns that you have inside the prefabs here. It's just gonna pick a number of these spawns. So because we have, recall that in this mob we have 20 to 25 spawns, it's just gonna pick about 20 to 25 enemies, and then you're gonna look through them and instantiate all of these enemies into the game. And then when you do that, then you will also have to figure out where do you want the enemies to spawn. Okay, and then for this, the formula is the X is basically, what I'm doing here is I'm taking the random angle, the angle that we are picking the enemies to spawn in, and then I'm projecting it in a certain distance. So over here, what we are doing is basically, if the player is right here, in a radius of 20 units around the player, the enemy can spawn anywhere inside here, anywhere inside this circle, or rather anywhere outside the circle. So enemies can spawn anywhere around the circle, and then once it spawns, it's gonna move towards the player. This is what the code here is doing. It's spawning the enemy outside of a certain radius, and that is basically what we are doing with the mob event data. So if you want to create a flower wall, you will have to create another set of event. You have to create another event data, and that will look like this. So I'm just gonna go into, let me just create a flower wall first. Let me just download the images, and then create the flower wall. So I'm just gonna create the enemy for the flower wall first, So it's just going to be the same process as the zombie and the skeleton. Let me just grab the sprites, drop it into the art folder. And over here, again, we want to set this to multiple. And then I can go to the sprite editor and slice. So this will be an 8x8 slice. And then I can apply. So once it's done, I can just create the flower wall enemy, right? So same process. I'm gonna grab the skeleton, unpack the prefab. And from there, let me just assign the prefab that I want, which is the flower, right? So we have a green monster here. And if it's too small, again, what you want to do is go to art and just set the pixels per unit to a higher value. I'm just gonna set these to be 30. Make it a bit bigger, maybe 25. Even bigger. There we go. And I will set this to filter mode point to make it pixelated. And this gives me my flower enemy. Then let me just call this flower. And the health of the flower wall is gonna be very high, right? It's pretty difficult to kill, but then it has a low move speed. Maybe let's make it have low damage as well. But more importantly, I want the flower to not despawn at edge, so the flower should have out of frame action of none. And the collider, of course, we gotta set the collider. Just get the collider to be, say, this is pretty good. 1.3, maybe 0.4 like this. So after that, we've got to set the animator for the flower as well, and for that, it's the same thing. I've got to create a new enemy for the animator override controller. This will be flower animator. I can use any of the animator controllers as a template, and then I've got to create a new animation for flower move. Flower move will be assigned to flower animator. And then after that, I can assign this flower animator to the animator of the flower. And from there, I can set an animation for this flower, right? So let's go to animation here and let's grab the flower sprites. And let's just put in a couple of frames of animations for the flower. So what the flower will do is the flower will animate as, yeah, and then from here I can go back to the animation and make sure that I set the animation of the flower to be looped, and the flower will start moving towards the player. Yeah, but it's gonna be a little bit slow, right? Flower, which is totally fine. Then now we just need to spawn the flower in a ring every time the event fires. So let me just prefab the flower and I can delete the flower. So go to enemies, I'll prefab the flower. So to spawn the flowers in a ring, we will need a script that is called ring event data. And the ring event data is gonna be similar to the mob event data, but there will be some pieces of logic that are different. Let me just create the ring event data script here. Ring event data. So the ring event data, right, has an activate function that basically spawns enemies in a ring. We don't need this section over here. Back. So this should be gone. Okay, so what this ring event data does is that it basically generates a bunch of game objects in a circle around the player. So what's happening here is, let's just create a new ring event data together, and then you can see how this works. All right, so I'm just gonna create a flower wall asset. This will be a ring event data. Create event data ring. And from here, let me just set this to flower wall. So the flower wall has a different set of properties because it's a different kind of event data, right? And the properties are again set inside the ring event data script. So what we have here is basically we have to spawn the flower wall, we will just set the spawns per tick to, let's say, 40 to 50. And duration will just be 1 because I just want one ring to appear, right? And most importantly, let me just set the flower prefab into the flower wall. So let me just lock this. And then after that, we can find the flower wall prefab inside our project and then put it here. So we want the flower wall whenever the event fires to spawn a ring of flowers around the player. So I'm just going to go to enemy spawner and I will add the flower wall inside here. And then what this does is that now every time an event fires, it will either be a bad mob or there will be a flower wall. So let's wait for 10 seconds and let's have the event fire. You'll see the flowers in a while. So now we have just some bats spawning. Let's see if 20 seconds we can get the flower. You'll get a ring like this. Alright, it's pretty nice, right? So this is how the flower wall event works. And because in the game, right, the flower wall doesn't actually spawn in a perfect circle. Our flower wall over here actually has an option for us to scale the X and the Y value. So what I'm going to do is just make the flower wall appear but in a more oval shape. Yeah, so the scale will control the shape of the ring. The radius will control the size of the circle, and then there is a lifespan here, 15 seconds, that controls how long the flower will stay on the screen. So you see when I set the scale to a different value, you will see the flowers will spawn in a slightly different format. Yeah, so the lifespan of 15 means that after 15 seconds, the flower wall will disappear. So what is this spawn effect prefab? This spawn effect prefab is basically when the flower wall spawns, right? You want to play some particle effects on every point that the flower wall spawns. If you want to do that, you can assign a prefab. So let's say if I assign, let's say just some simple VFX here. Let me just assign a basic one. Let me assign the block VFX. Just a basic one to show you how this works, alright? Just gonna go to flower wall and then find my VFX here, which is under prefabs, VFX, block VFX. Okay, so this means that a VFX will play whenever a flower wall spawns. Okay, you've got to set a high value to the spawns per tick here for the flower wall. Otherwise, the flower wall will not spawn with enough flowers. Looks like the effect didn't play. Gotta figure out why. Did the effects play? I don't think it did. Flowers spawn, but the effects didn't play. So it means that I'm missing something in the code here as well, huh? Spawn effect prefab. flower wall should be spawning, man. We have so many bugs in our code today. Let's find another flower wall and see whether it spawns with an effect, because it doesn't seem to be doing that. Is my flower wall spawning? No, it's a mob of bats. Let's wait for 50 seconds then. Is there an effect that plays? Doesn't seem like that an effect plays when the flower wall spawns. Oh, the effect plays, it's just not obvious, huh? Let me pick a different effect then. I think because the effect I picked was too subtle. Let me just put the lightning VFX to show you my point. Alright. So what this means is that whenever a wall of flowers spawn, then a lightning strike should play on all the flowers. Let me just see if we can get the flower wall up here. See that? So if you assign a nice prefab over here, then you will get, you will get very interesting effects. Let me just show that to you again. See that? So the spawn effect prefab is just there for you to get very nice effects for when enemies are spawning. And if you look at the video where we talked about how to add sound effects to your VFX, you can create some very nice visual and audio effects for all of these spawn events. Oh, I really like the lightning strike over there, man. Like the lightning strike effect. It really gets the point across. So that's about it for this part, really. So let me just run through the ring event data. So what we are doing here is we are just spawning flowers in a whole bunch of angles. So what we have here, math pi is 180 degrees. If you multiply that by 2, that's 360 degrees. And then because we have a number of spawns, right? So let's say if we are spawning 40 flowers, we will take the degrees over here and divide it by, let's say if it's 40 flowers, then it'll be 40. And then after that, this will give us 40 different angles. And then we will just spawn a flower in each of those angles. And then we project the location of the flower by taking the distance and then multiplying it by cosine and sine. These are called polar projections. And then what this does is that this will cause us to have, so for example, if we are here, then it will spawn a flower here, then it will offset and spawn a flower here, and offset and spawn a flower here, and so on until you get a big circle around the player. Okay, so this polar projection formula is pretty complex, but we are going to include a link in the description of this video just to link you to an article that explains how this polar projection thing works, because this involves a whole bunch of math, and I think this video is really long enough, so I don't want to get into that at the moment. So if you want to create more events, different kinds of mobs and stuff, you're going to have to create more event data scripts. So what we're gonna do is that for future events, we are going to probably make some posts on the community forums similar to what we have been doing right now. If you look at the community forums, there are guides on how to create other weapons right here. Okay, so we're also going to create guides for how to create different kinds of events for different kinds of enemy configurations. All right, so that about wraps it up for today's video. In the next part of our series, what we are going to do is we're going to explore adding more stats to enemies. So if you recall, in a previous video, we talked about how to introduce more player character stats, right? So you will see our character actually has many stats here now, as opposed to previously where they only had 6. So right now our enemies they have the same problem, they only have 3 stats. But if you look at enemies in Vampire Survivors, right, they have actually a lot more stats. They have health, they have power, they have speed, knockback, experience, and a whole bunch of resistances. So we are gonna implement these as well. But to do that, we are gonna have to revamp the enemy stats script a little bit. And this allows us to achieve certain things that are not possible now with our current enemy system. So if you look at our flower, for example, it's very easy to knock them out of the way. But if you play Vampire Survivors, you will know that it's actually pretty difficult to get the flowers to move, right? Whereas you see right now, I can just slash the flower and they'll move away. See that? So we're gonna introduce a new stat called knockback resistance among other stats, and then this will allow us to more accurately represent what's happening in Vampire Survivors. Okay, but even with the current system now, I think things are pretty interesting, right? Because now you're able to get enemies, you're able to get events happening, so you have the flower wall, and yeah, it's all very exciting. So I will share the most updated project files on Patreon, and then you can go and have a look at them. And I hope you enjoyed this video, and I'll see you in the next part. So we're gonna start work on the next part in the next stream that I'm gonna be holding probably on Thursday. Our streams are gonna be on Thursday for the next couple of weeks. So stay tuned, and as usual, thank you for your support, and really excited about this new enemy spawning system. Okay, so I'm gonna end the stream here, and stay tuned. Keep your eyes peeled for the next part. It does, right? It does make it feel like a game, right? We're really getting there now. Let me just check if there is anything else I need to mention. I don't think there is. Okay, I'm gonna head off now. So I'll see you all. Project files will be updated in a couple of minutes.